Want to be able to look at a picture that demonstrates sort of the length of a cluster of waves and be able to determine the wavelength of just a single wave. And so for this first one, you can hopefully you can see that there are 4 complete waves. If I start here, I go up, come down, and then come back again to the original position. That's one wave. And then you do it, so there's a wave here, then you do it again, again, and again. So there are 4 waves making up this picture that I see. And so one wave would have a length of 72 millimeters divided by 4, or 18 millimeters. So that would be one wavelength. If we take a look at this next picture, it's a little harder to see, but again, I'm going to use the same process that I just did, where I go, okay, so there's one wave, 2, 3, 4. So I'm noticing that this wave starts at the center, it goes up, down, and then back to the center. So I'm stopping every time I hit the center again, but after completing a full wave. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 waves. So I take my 1.2 meters and divide by 9. I made this a little bit more complex than I wanted to. Give me a second here to figure that out. All right, hopefully I'm doing my math right here. 0.133 repeating meters. Should have figured that out in advance, sorry. All right, this next one here. Okay, so if I start here and I look to see a full wave, well, this isn't even a full wave, okay? This is only half of a wave. I apologize for my line not coming at that same point. This is not even a full wave. This is only half of a wave. So another way that I could do this question is I could sort of write a quick equation, and I could say 1/2 of a full wave is equal to 70 centimeters. And then I could solve this equation. Here I can see that I have to double 70 in order to find a wavelength. Now some people can just sort of see that and do that logically in their head, and that's fine. This just gives you a method in case you have trouble with it. All right, and then this one, so I have a wave, and then I have a half of a wave. Okay, so again, I could set up an equation. I could say, okay, so I have 1.5 waves, and that is equal to 24 meters. And then I could go through and do my math. That's one way of doing it. You'd get 16 meters. Another way is to just sort of break this whole problem into 3 parts. I can see there's a half of a wave here, a half of a wave here, and a half of a wave here. So I can see that each of these parts would have to be 8 meters, and then a full wave, an up and a down, would have to be 16 meters. Okay, so however you want to think about it, but you need to be able to look at a picture and figure out what the wavelength would be.